Welcome to All Wired Up, where you dive into exciting topics around tech, innovation, AI, and the future of digital life. Strap in, subscribe, and enjoy the journey.
Welcome to All Wired Up. Today we're diving into Kubernetes for absolute beginners. For many, just hearing the word Kubernetes sends shivers down their spine. It conjures images of complex command lines, intricate configurations, and an exclusive club only for the most advanced engineers. The common myth is that Kubernetes is an insurmountable mountain, reserved solely for the tech giants, with vast teams and unlimited resources. But what if I told you that is simply not true? You don't need to be a coding genius or have years of DevOps experience to grasp the fundamentals. Kubernetes, at its core, is built on just a few essential ideas. Understand these, and suddenly, that intimidating mountain looks a lot more like a series of interconnected, manageable steps. In this crash course, we're going to demystify Kubernetes by focusing on its four foundational building blocks: pods, nodes, deployments, and services. Think of them as the four cornerstones that hold everything else up. Once you understand how these work together, you'll have unlocked the heart of Kubernetes. At its core, Kubernetes exists to run your applications reliably and make them accessible to users no matter what. The beauty is in its ability to manage complexity behind a deceptively simple flow. Imagine your user making a request. That request travels through a service, which directs it to a pod. That pod is diligently running on a node, and it's all orchestrated by something called a deployment. Don't worry, we'll break each piece down. Let's start with the smallest yet most crucial component, the pod. In the simplest terms, a pod is like a tiny, self-contained apartment for your application. When you containerize an application using something like Docker, that container needs a place to live in Kubernetes. The pod is that wrapper, that cozy home for your single application container. While a pod usually contains just one application container, it can hold more if those containers are tightly coupled and need to share resources, like a main app container and a sidecar logging agent. What's key is that containers within the same pod share the same network space and storage. And here's a crucial point. Pods are temporary. They can be created, destroyed, and recreated. If a pod fails, Kubernetes can simply spin up a new one, ensuring your application stays available. For example, imagine your simple web application, maybe a basic blog or an e-commerce storefront. That entire application, running as a Docker container, would reside inside a pod. This pod provides the runtime environment and resources it needs to function. Simple, right? Next up, we have the node. If pods are the individual apartments for your applications, then a node is the actual physical or virtual machine, the building, where those apartments exist. It's the computing horsepower that actually runs your pods. This could be your laptop if you're experimenting with Minikube, or more commonly, a robust cloud virtual machine from providers like AWS, Google Cloud, or Azure. Each node comes equipped with the essential tools needed to be a part of the Kubernetes cluster. It runs Kubelet, which is the agent that communicates with the Kubernetes control plane, telling it about the pods on that node and receiving instructions. It also has kubeproxy to handle network rules and traffic, and a container runtime, like Docker or Containerd, which is responsible for actually running the containers inside your pods. So, when Kubernetes decides it needs to run a new instance of your application, it doesn't just magic it into existence. It carefully schedules that pod onto an available node, ensuring the node has enough resources like CPU and memory to host it. Nodes are the foundational infrastructure where the rubber meets the road. Creating pods one by one would be tedious and, frankly, not very cloud native. What happens if a pod crashes? Who replaces it? What if you need more instances of your application during a traffic surge? This is where the deployment comes in, acting as the intelligent manager for your pods. A deployment is essentially a blueprint that tells Kubernetes how to create and manage a set of identical pods. You tell the deployment, I want 3 copies of my web application running at all times, and the deployment makes sure that's always the case. If one pod dies, the deployment notices and automatically spins up a replacement. It's self-healing at its best. Beyond just maintaining a desired number of pods, deployments are powerful for scaling. Need 5 more copies of your app? Just update the deployment, and it instantly creates them. And when it comes to updating your application, Deployments handle rolling updates, gradually replacing old pods with new ones, ensuring zero downtime. If something goes wrong, it can even roll back to a previous version seamlessly. For example, you might create a deployment that specifies, quote, I need 4 replicas of my blog application, using this specific container image, and if any of them fail, bring a new one up. The deployment then handles all the orchestration, ensuring your blog is always available to your users. Finally, we come to the service. Remember how pods are temporary and can come and go, with their internal IP addresses changing frequently? This presents a huge problem if external users, or even other applications within your cluster, need to consistently connect to your application. How do they find it if its address keeps changing? The service is the solution. It provides a stable, unchanging IP address and DNS name for a set of pods. Think of it as the permanent street address for your application, even if the residents inside the pods are constantly changing their apartment numbers. A service also acts as a load balancer, distributing incoming traffic across all healthy pods it manages, ensuring efficient use of resources and high availability. There are different types of services for different needs. A. Cluster IP. Service is only reachable from inside the Kubernetes cluster. A. Node port. Service exposes your application on a specific port on every node, making it accessible from outside, and most commonly in cloud environments. A. Load balancer. Service creates an external, cloud provider-managed load balancer, giving your app a public IP address. So if your web application runs on multiple pods, a service would sit in front of them. When a user requests your website, the service receives that request and intelligently forwards it to one of your healthy web app pods, making sure no single pod gets overwhelmed and your users always have access. Let's put it all together one last time. Your applications run inside pods. These pods live on nodes, which are the machines providing the computing power. Deployments act as the diligent managers, ensuring the right number of pods are always running, scaling them up or down, and handling updates. And finally, services provide the stable access point and intelligently distribute traffic to those pods. So to recap, a pod is your application's home. A node is the machine running that home. A deployment manages the homes, keeping them safe and numerous. And a service is the stable address and traffic director for those homes. If you understand these 4 concepts and how they interact, congratulations! You've not only climbed the first few steps of that Kubernetes mountain, you've mastered its very heart. Kubernetes might seem daunting at first, but by breaking it down into these core building blocks, you can see it's a logical, powerful system designed for resilience and scalability. You've taken your first major step from zero to understanding the hero of modern application deployment. Keep exploring, and you'll find the rest of Kubernetes surprisingly intuitive. Thanks for watching. Don't forget to subscribe and share. See you later. Be awesome.
I hope that was insightful. Thank you for watching. Don't forget to like, subscribe, and share. Be awesome.